Okay, from lab section number 3, we have example number 1. Here we are about to discuss a new concept, that is sections. Sections are being used for task parallelism. The way we use Pragma OMP parallel for loop, where we were doing the data parallelism, where we provided multiple iterations to the threads with respect to data, and then it will execute and complete its work. What we do in sections, we create the block of the sections first, and we assign one section to each thread, and whatever the code we will write in the section, that would only be provided to that thread, and thread will execute it, and finally we'll move on for the joining. Here this is our example where we have created two functions that we will provide to two different threads. In the sections, function A will just print that it have been executed by which thread. Similarly, function B do the same task. We have set up the number of threads in the main function as 2. We may change it to check the code. We have created a parallel block here so that these two sections would going to execute in parallel. And then we have a section block where we have defined two different sections for each function, that is for A and for B. As soon as it will call, one thread will be given one section, that is function A section to be given to the thread, and another thread would be given function B's section. Now let's compile it and run it. So we have demonstrated that there were two threads. Thread 0 executed function A and thread 1 executed function B. So to practice, we can do one more thing over here, that we will increase the number of threads. For example, I'm changing it from 2 to 4. Now what will happen, that 4 threads would going to be created, but as one section would going to be assigned to one thread, then 2 threads would be idle and will wait for these 2 threads to be free. As already told that we have 4 threads, 2 will going to be assigned to sections, 2 will wait. And meanwhile, no execution would going to be performed to those threads. So now with 4, let's recompile the code and run and test it. So now we can see that thread 0 got the function A, and thread 2 got the function B, and thread 0 and thread 2 executed the function, whereas thread 1 and thread 3 are idle. That's why they were going to wait for thread 0 and 2 to be completed. Because when Pragma does thread creation, it actually create all the threads at a time and assign the task. If any thread didn't get any task, it will go to the boundary and wait for the other threads who got the task and that are in running state right now. When all the threads would reach to the boundary, then the final outcome after the join will come. That's why I told that the remaining 2 threads are in the waiting list rather than these. Okay students, now let's move on to the example number 2 of lab session number 3. Here we will use a single block of Pragma whose primary objective is to give the task to the thread for execution. We will write the code over here. In this program, we have a function where we have these 3 integers and 1 array. Integer I is for iterations, n is basically number of iterations, a is the variable for definition, and the b is for result for arrays. For the timing, we have taken up 2 threads. We will change it and we will check what happens. Here we similarly use Pragma OMP parallel block already discussed, where we have done A, B and shared already discussed in the previous lab sessions, I being made private. Now this is important Pragma OMP single block. Single block will tell the thread to execute this block, and whoever the thread would be waiting, and that thread would be waiting to complete execution of this block till the end. As for now, we have only 2 threads. Obviously, one thread would going to execute this single block that sets A value is equals to 10 and will also print that which thread have printed this single block. Now after the execution of this single block, then we will proceed towards the for loop. Here the total task would going to be equally distributed among the both threads. Means if we will have odd number of iterations, means that is not matching to the number of threads with the number of iterations, the Pragma will do itself distribution and tell the thread to perform. We have also used the print statement over here, tells which thread perform which iteration. This code is basically initializing a is equals to 10 first and places in every value of b the value of a, which is essentially 10. So every iteration of or element of b must be 10. And after that, when all the loops are going to be run and when the total parallel block would going to run, after that our compiler will run this code. Its work is to just print that b every value holds what. Now if you will compile it and then run it, now we can see that single construct have been executed by thread 1. There were two threads, one was 0 and another was 1. After that, the iteration that have been performed, 5 iterations performed by thread 0 and the 4 iterations performed by thread number 1. Whoever thread performed the single construct execution, that thread will get the iterations later on. Means thread 0 was waiting meanwhile the single construct was executing. So thread 0 was initially free and then he got the work. And we also know that the thread 0 by default is a master thread. So usually master will get the things by default more. These are our iterations performed from 0 to 8. And after the parallel region, we have printed out the output of array B. All elements of B printed. We can also check after increasing the number of threads. Let's do 4. It will not change or impact as much. Again, any one thread will going to execute the single block. After that, this for loop will going to divide for 4 threads equally. And the output will print which thread performed which particular iteration. Let's recompile and run the program. We can see that again thread number 1 performed the single block. After that, all iterations performed. 0 have taken up 3 iterations. Thread 1 taken the 2 iterations. 3 also performed 2. Thread 2 also performed 2 iterations. 4 threads have been divided of 2 patches. An extra iteration being given to the master thread 0. Output is same, placing essentially A's value into all B elements. Okay students,